Okay, now next topic in our chapter is types of chemical reactions. Students, based on the behavior of the chemical reaction, okay, based on the behavior of the chemical reaction, what what is the process going on in the chemical reaction? That means either the elements are getting added, or removed, or vaporized, or diluted, or solidified, or liquidified. What the behavior of the what is the behavior of the equation? Based on that behavior, the chemical reactions are classified into some various classifications, such as combination reaction, uh, decompose reaction, oxidation and reduction reaction, and followed by the decomposition reaction, etc., etc. So one by one, let us try to understand the types of chemical reactions. Very first type is in the chemical reaction is the combination reaction. If to try to understand this kind type of chemical reaction, let us take one activity. Nothing to do. Just take some calcium oxide or a quicklime in a beaker. Add slowly water to this. Touch the beaker below at below side. Do you feel any change in the temperature? So if we express this operation in chemical form, we will get a chemical reaction. That is carbon monoxide, which is nothing but the lime, quicklime, is added to hydrogen, which is in liquid form. Carbon monoxide is in solid form, hydrogen is in liquid form. This gives rise to carbon slake lime, carbon hydroxide plus elimination of heat. Right? Got the point? This is combination reaction. Why it is called as combination reaction? Do you understand? Because in this reaction, two elements are combined. One is lime, that is carbon monoxide. Second is water, that is H2O. When these two elements are combined, it gives rise to a product by whose name is carbon monoxide by elimination of heat. Right? And let us observe that carbon monoxide which we are adding in the water is in solid state and water is in liquid state, but the product what we are getting is in aqueous state. Okay, because we are adding the elements, we are adding the substance, we are combining the substance, so it is called as combination reaction. Right? Got the point? Understood? Any doubt? Similarly, many more examples we can give. Burning of coal. Burning of coal means carbon. Coal is nothing but carbon. It is just a carbon, nothing else. When we add oxygen to it, that means when we burn it, in presence of oxygen, it gives rises to carbon monoxide. Sorry, it gives rises to carbon dioxide, which is gas. So, if we burn if we burn uh, coal, which is nothing but the carbon, we are burning, that means we are doing this process in presence of air. So the air is added to it. Because of the addition of air, it gets converted to carbon dioxide, which is gaseous form. Carbon is in solid form, oxygen is in gaseous form. The result we are getting is carbon dioxide gas, which is in gaseous form. So here we are combining. What we are combining here? We are combining carbon with oxygen. We are adding. We are clubbing. We are attaching. We are joining. This type of reactions is called as combination reaction. Third example, we can take formation of water from H2 and OS. If we add two atoms of hydrogen in the gaseous form, if we add one atom of oxygen in the gaseous form, these two combination give the result to one drop of water. Simple. In this we are combining the hydrogen and oxygen. What's the point? So these are called, these all are combination reactions. Okay. Now again in this reaction, we are again having two types of reactions, that is endothermic reaction and exothermic reaction. The reaction in which heat gets combined, heat is not allowed to evaporate, heat is getting mixed with the reaction, that kind of reaction is called as endothermic reactions, right? The reactions in which heat gets combined, heat is not evaporated, heat is combined, heat is not evaporated, it is combined with the reaction, that kind of reaction is called as endothermic reaction. And the reaction in which the heat gets evaporated, the heat gets fly off, is this kind of reaction is called as exothermic reaction. Let us take the example of exothermic reaction according to your textbook. Burning of natural gas, carbon hydroxide, sorry, carbohydrates. Okay, carbohydrates. When we burn when we burn carbohydrate, which is in the gaseous form, in presence of oxygen, it gives rise to carbon monoxide plus water. And this carbon monoxide is also in the gaseous form, water is also in the evaporated gaseous form, even carbon hydrate is also in the gaseous form, oxygen is basically naturally and already is in oxygen gaseous form. So when we club these two, this is basically chemical combination reaction, but again in that it is endothermic exothermic reaction. Why? Because the heat is allowed to evaporate from the chemical reaction. Okay. Again, once again example, let us take glucose C6H12O6. Glucose, when it is added to oxygen, that means when it is burned in presence of oxygen, it gives rise to carbon monoxide plus water plus energy. Carbon monoxide is in aqueous form, water is in liquid form, and energy. So this type of equations are called as chemical equations are called as composition reactions. Now next type is decomposition reaction. Decomposition. Now next type is decomposition reaction. Students, this type of reaction is nothing but the reverse process of composition reaction. Okay, in composition reaction, what we were doing, we were clubbing, we were adding, we were combining, we were attaching one and more than one elements here, and there we were getting product as one element or one or more elements. But here in decompose this type of reactions, we decompose, we separate, we detach, we remove more than one elements from single element. Okay, for example, let us take decomposition means we decompose single element into various different elements. For example, ferrous sulfate, FeSO4, it is one single element. When it is heated in presence of oxygen, when it is burned in presence of, this is only single element, it is not individual types, this is single element bounded with each other. Ferrous sulfate, Fe2FeSO4, two elements of FeSO4, we are heating two elements of FeSO4. What it gives, in presence of heat, it gets converted to ferric oxide plus sulfur dioxide plus sulfur monoxide, sorry, plus sulfur trioxide. It gets converted to sulfur dioxide plus sulfur trioxide plus ferric oxide. So here it is only one element, ferrous sulfate. When we are heating, when we are burning that, okay, when we are burning in a boiling burning tube, it gets converted to three elements, that is one is ferric oxide,